Hello, my name is Nagela Nukuna, and this is my video describing the physics concept constant velocity motion. My experiment showed a pencil sharpener that I rolled across a flat table. This experiment effectively portrayed the purpose of this lab, which was to observe, track, and analyze any object moving at a constant, steady velocity. The results that I garnered were that an object with a constant velocity with a net force of 0 will remain stationary or move with a constant velocity, which means that my sharpener was moving at a constant speed and in a constant direction. This is because velocity is a vector quantity with both magnitude and direction. The core principle that was demonstrated in this lab was Newton's second law, or the momentum principle. As you can see here, for a short enough time interval, the change of momentum is equal to the net force acting on an object multiplied by the duration of the interaction. This equation can be simplified further into terms of velocity, net force, and the mass of the object. Here you will see my experiment video in real time in a system called Tracker. As you can see, we can now analyze our system, the pencil sharpener. There are no outside forces acting on it besides me rolling it on the surface. The measurements were calibrated to the length of the sharpener, which was 3.5 centimeters as denoted by the blue line. Our axis is defined in pink. The clip starts slightly before the origin of the system is reached, and data is collected once this origin is reached at time t equals 0.43 seconds. The sharpener travels in the negative x direction according to my axis. As the sharpener rolls, it maintains a constant speed. Here we go into the VPython code, which was used to make a model of the experiment that you just saw. The mass is initialized in kilograms as 1 times 10 to the negative 15th kilograms, as you can see under the edit this line. Next, I initialize the position, velocity, and time. You can see that the position and velocity are both in vector format, which is why it has a parenthesis 0, 0, 0 for position and negative 11.6900 for velocity. I calculated this number for the velocity by taking 2 initial position points and dividing them by a change in time. It is in the first spot because my sharpener traveled in the negative x direction on the table. My delta t was 0.01. Here is the net force, new sharpener velocity, new sharpener position, and the continued clock as t equals t plus delta t. That the colors on the top arrows correspond with the colors on the bottom in the code. This was the calculation for the new position, and this is the formula that it was derived from. And here was the formula that the new velocity was derived from, Newton's second law, or the momentum principle. So what does the VPython code create? As I said before, it creates a model of the experiment that I did. Here, let's look at it now. So it moves from the origin and left in the negative x direction. The spreadsheet plots the observed positions and the model position on a position versus time graph. So here you can see that my experiment line in blue is over the model line. Usually, you might see it underneath the model line because you would think that as the object travels across a surface, it would decrease in speed. However, in my case, when I rolled the sharpener, I managed to catch it as it was still speeding up rather than slowing down. In addition, the sharpener had a shape which may have altered the results as it wasn't a perfect sphere or even a perfect cylinder. However, on this blow up here, you can see that it actually hit a peak and began to decrease. So given more time, the experiment position may have met and most likely would have decreased past the model position. This decrease would be due to a net force in the direction opposite the direction of motion. This can most likely be attributed to a slight amount of friction and drag forces. The model did not take this into account. However, drag forces are proportional to velocity. As there wasn't a very high velocity, the model still holds reasonably well with the experiment. So what if I switched my axes? The graphs would be reflected, so I would have a positive position instead of a negative one. However, the F net would still be the same vector, 0, 0, 0, and the acceleration would also be equal to 0 due to Newton's second law. What does it mean? Well, I set my net force equal to 0 right after the sharpener left my hand. In addition, the x direction had forces of friction, wind resistance, and the sharpener shape. The y direction had gravity and normal force. Here's a summary. Thank you very much. The objects with a net force of 0 are either still or moving at a constant velocity. This was proved through modeling and graphing and analyzing the video of a constantly moving object. The experimental data did a reasonably accurate job in describing Newton's second law, as my graphs followed the same general trend. Thank you very much.